All right, ladies and gentlemen, Chem 111, we got a test coming up. And it's on the syllabus scheduled for this Wednesday. That's in 2 days. I don't know if you're ready for that. So are you ready for test number 2? And I'll just write it really small because you don't want to brag about stuff like this. Uh-oh. Oh. Yeah, there we go. I am not either. Oh, okay. So let's make it look official. Test number 2 is moved to Monday. It's not moved very much. Monday, and I don't have my watch with me, but my computer says today's the 7th and 14th would be next Monday. Monday, November 14th. Be here right at 9:10 or a little earlier. Okay. Looks pretty official. Gotta make it big and official. And red's nice color. So we got it. With that in mind, that's official. It's going to be in our notes and everything. Okay. Now we got an activity, and today we have 3 activities that are all linked. So every activity today is based on this beginning activity. And I am going to give you a lot of steps as we go. First part, a little more straightforward. There's no steps indicated here because the questions kind of have the steps. But as you'll see in your next activities, I give you some steps, and some more steps. And you're going to have a combustion reaction that's a big part of test 2. So you really have to know when you're told the formula of a fuel, where you go next. And you write down the formula of the fuel. I'll give you the name and the formula. You see it there? It's called paraxylene. You don't need to know its name. C8H10 is all the important thing right there. So we're going to give a complete balanced reaction by starting with C8H10. And who remembers what that has to react with in a combustion reaction? O2, thank you. He could have said oxygen and he would be saying the same thing, right? Because O2 is a diatomic element. And the gentleman that answered probably knows his have no fear of ice cold beer. That has all 7 diatomics in that little memory trick, right? And then we have to know the 2 products of combustion. And what are they? Yes. Some of you have been studying already. I like it. He said CO2 and H2O. All right. Make sure you get that activity back there when you're coming in. And so A, we're on our way, but we're not balanced, are we? We got our formulas. Got our formulas, and in this one, you can start with carbon. Students like starting combustion with carbon. They can also start with hydrogen. So talk to me about, if you start with carbon, what you want to do. Balance out the carbon. Balance out the carbon. I was trying to direct this young man to an activity right in front of him. All right. So how do you balance out the carbon?
I put a 2 in front of C8H10 on the left.
Oh, wow. Were you studying ahead and doing shortcuts?
I watched the YouTube video on how to do it a little easier.
Yes. There are tricks to doing a combustion reaction that can save you steps later. And I'll give you the trick. I'm not going to do it that way. It's a nice trick. And if you're ahead of the game and you're comfortable doing it straightforward, like we always do, and you see this trick and you've become good at using it, use it. It's a beautiful trick. And it says there's only two scenarios for any combustion reaction. There's the scenario where you balance it and there's no fraction. That's scenario one. And then you're done. And scenario two is you balance it and you got a fraction in there. And with combustion, the worst fraction you ever get is a half. There's a half in there somewhere. So you're going to multiply by 2 to fix that, right? Well, his videos that he was watching, I don't know, one of them might have been mine. I don't know. I've done one in the past. But in those videos, it says if you take the number of H's in your fuel, which is currently it's 10, right? And you realize that half of 10 is 5, and that's what's got to go in front of water, right? Think about it. 5's an odd number, isn't it? You're putting an odd number in front of water, which has an odd number of oxygen, 1. So you're going to get odd oxygen. And then you're going to add an even oxygen from CO2. So it's going to be odd still. You're going to get a fraction, right? Because an odd number, how do you get it here? You got to have a half in there. So he watched the videos and it said, go ahead and start with the 2 right here because you're going to do that and then balance from there. Great idea. Saves you a step at the end. We're going to do it with the step at the end. It's not even harder. So starting with C, traditional way, you've got 8 of them on the left. How do you get 8 of them on the right? I want to hear your words carefully. Yeah. I like it. She knows I don't like the word add in this circumstance. So she said place an 8 in front of CO2, and I like the way she said it. Or she could have said multiply the coefficient by 8. That's what she did. And your carbons are taken care of. Hydrogens, I need half of 10 because I got 10 in my fuel, and something that multiplied by 2 gives 10 is 5. And you see I have this situation now with oxygens. Once you've committed to the 2 products, you must add the oxygens. And 8 CO2 says 16. And 5 waters only has 5, that's 21. All right, and 20, guys, you don't have to do the math either. You know you're not done. You can just write 21 over 2. 21 over 2 times 2 is 21. You know that without doing math, I hope. Please, tell me you know that. Okay. There you have the scenario where you have a fraction, right? So what's the fix when you have a fraction? Multiply by the smallest possible integer to get rid of the fraction. So I'm just copy pasting because, you know, teachers can do that. And everything gets eliminated. Multiply the first one by 2. I'm going to go with purple. Second one was 21 over 2 times 2. That's why I didn't do the math. 21 over 2 times 2 is 21. Don't you'd be undoing the math. And 8 times 2 is 16, and 5 times 2 is 10. Congratulations, you've got the complete balanced combustion reaction with the burning of paraxylene. Wow. If you're a jeweler, you like paraxylene because you use it to clean jewelry. It's excellent for removing organic dirt from metals. You get the dirt right out of there. Anyway, TMI. And what are we doing? Convert the, how many moles of carbon dioxide will be produced in 1.452 moles of paraxylene are completely burned? And I just want to remind you how to read a chemical equation. You can read it like a physical chemist who says 2 molecules of C8H10 react with 21 molecules of O2 to give 16 molecules of CO2 and 10 molecules of water. You can say it that way, right? But chemists don't talk that way. It's useless. Why? Because nobody sees atoms and molecules, right? You can't feel them, they're too small. So what word do we use instead of molecules? Oh yeah, we don't want to talk particles either, because now in terms of numbers you can feel and touch and measure, the number of particles is too big. She said you could use the word particles instead of molecule. Particle is synonymous with molecule. I wasn't looking for synonymous. I was looking for a number of counting that, you know, when the people selling you paper sell you 25 million pieces of paper, they're not going to say that. They're going to say a certain number of reams, right? Yeah, the word is moles, and we better be happy with moles by next Monday. Why is he saying next Monday? You might want to read page 1 if you came in late. Okay. So moles. How many moles of carbon dioxide? So I'm going to read this equation, and I'm going to write out how to read it, because this is how you use stoichiometry. Here's how you read the equation. Read the equation. 2 moles of p-xylene react with, what is my next part of this sentence? How's it continuing? Help me out. Where did I get the 2? It's got a name, this number 2. He said from the C8H10. He's correct. What's the name of the 2? No, that's how we use the 2. He's going to use the S word, the stoichiometry word. But what is 2 and 21 and 16 and 10 in this question? They have a name. It's important. They're called the coefficients. Thank you. Coefficients. And there's only one thing coefficients are good for, and I only want to see it used once in any problem ever. Students love using the coefficients where they don't belong. It's only good for one thing: converting moles of one substance to moles of another. So if you're not in if your numbers aren't in moles yet, you can't use these coefficients. Is this clear? If you don't have moles, you can't start using coefficients. Okay? And I'm going to finish reading my sentence here. 2 moles of paraxylene react with 21 moles of oxygen to produce, I spelled oxygen wrong, to produce, to yield, to give, whatever synonym you can give to making, 16 moles of carbon dioxide and 10 moles of water. That's how you read the equation. That is the practical use of stoichiometry right there. We use purple already. Yes, orange is nice. And a little bigger. Not much. There you go. Read the equation. Trying to move the equation. There. We good? All right. So B. We're already at moles. Hey, if you're at moles, you can use the coefficients to go from, wait a minute, what are the coefficients used for? Tell me. There's only used for one thing, coefficients. You need to be able to tell me the exact thing it's used for. Any coefficient, what's the only use it's good for? Yeah, very specific. Multiply, yes, it is good for multiplying. I can't disagree. That's a great answer. But it's only the first bit of the answer. Converting from moles of one substance in a balanced chemical equation to, what are we converting to? Moles of another substance in the balanced chemical equation. So yeah, we were a little rusty on that. Before this video is over, you're going to tell me that sentence a little more smoothly, okay? Because knowing what coefficients are for is critical. If you don't know what they're for, you're going to start using them randomly. And if you didn't get an activity, there's one right back there on the back bench. Okay, so we've got moles. Question B is got moles. 1.452 moles. But write down what it's moles of, people, or else it's a waste of time. Moles of what? Carbon dioxide. You can use the formula, right? And here's coefficient time. Coefficients in red all day or purple all day because we got purple already. All right, getting rid of moles CO2. And what's the question in B asking for? Which substance? It's asking for moles carbon. How many moles of carbon dioxide? Oh, I didn't write that. Yeah, see, somebody was going to ask me a question. Said you wrote 1.452 moles CO2, which was a lie. Okay, we don't like lies. Lies ruin life for everybody. What was the moles of? It helps. It's hard enough when we're learning new stuff and he's putting stuff down in front. Xylene, right? You want to write C8H10? It's just shorter. And then use, hey, my knowledge of using conversion factors says you messed up already, right? I want to get rid of that. So that's my denominator. Sure glad we caught this before doing any math. Hello? My computer lagging again. And I want, in the question, what do we want moles of? Now I finally got to that question. In the question B, it says I want to know moles of something. What is the something? Carbon dioxide. You said that. I'm sorry, I didn't hear you right. All right, thank you. And what? Hey, what numbers go in front? And they should be purple. What numbers go in front of these moles CO2 and moles C8H10? 16 in front of CO2. Where'd I get that from? The balanced chemical equation. And what goes in the moles C8H10? 2. Okay, and what are those two numbers called? Coefficients. What is their only use? This is perfect. Converting moles of one substance in a balanced equation to moles of another in the same balanced equation. Nice job. And I think that's the answer right here. You're going to multiply by, it looks like 8, right? So I'm ballparking while you're typing. Please, somebody type today. The longer it takes for you to type, the more you got to watch this video and look at dead air, okay? So you be typing for me, please. You don't want me doing the answers for you on the test because that's illegal. Okay, so you got to do it yourself. 11.6 and 1/6, and it's, let's see, moles xylene are gone, moles CO2, and I need, how do you know, let's see. Oh man, you know, I should make this question at least 2 sig figs. Okay. Oh, not that one. No, we're here, right? So that's the sig fig. Do you use these as sig figs ever?
No.
No, because they are exact, right? But my 1.452, how many sig figs, everybody? 4. So my final answer, 11.62 mole CO2. All right, we got a question over on the right side here. No, we don't. Okay. So we have how many moles? Good. Convert the answer to B to grams of carbon dioxide. Oh, wow. How do you do grams? How do you do grams? I got, yeah, I got this thing started last week. I don't know if you'll be able to see that in the video. And he said you got to convert moles CO2 to, oh, I need the molar mass of CO2. Okay, so molar mass, we're talking about C, molar mass. Now you'll see different people use different words for this same thing. Molar mass equals molecular weight for us, they're going to be interchangeable. Formula weight. And remind me how you can get the numbers you need for these. You have to look on the periodic table, and what are the red numbers units on the periodic table? AMU is not a very practical use because most people don't talk about one molecule or one atom at a time. An atomic mass, it's like tiny, tiny, right? We like stuff we can feel and hold and touch. That's why we started talking about mole. And then the numbers become what? Grams per mole. Well, yeah, any of these words, molar mass, molecular weight, formula weight, grams per mole from the periodic table. And this is the 7th time I've asked about the red numbers on the periodic table and what are their units. And I said, we're getting to 20. I wanted to do 20 last week, but you know, time's ticking. Okay, so now what's the chemical you're talking about? It's CO2, right? I kind of like FW for formula weight. It's just my preference. I know the lab people are more molar mass people, but please learn when you're saying molar mass, Dr. Whitaker just likes calling it formula weight. Okay? I'm too old to change. Don't say that. I can change too. I'll try to say molar mass every time I say formula weight. How's that? Okay. And you're going to do CO2. Notice what I'm not using right now. CO2, I'm using 1 C, 2 O's, not 16 C's, not 32 O's. Because to do that, I'd have to use the coefficient. Do we use coefficients to figure out formula weights, also known as molar masses? No, what's the only thing we use coefficients for? Say it again, you were so smooth last time. What's the only thing coefficients are used for? Converting moles of one substance to another, not to figure out a formula weight. Okay? Be very clear. I'm only bringing these things up because I see them every year and they're wrong. And it's because students didn't know what the coefficients were for. Okay? And we got 12.01. Remember, my periodic table that I hand you on Monday, November 14th, has 4 sig figs for every molar mass, also known as formula weight. 4 sig figs. So I'm only going to use 4 in the lecture notes every time. Okay. Plus 2 times 16.00 equals 44.01. What are the units for that number? Grams per mole. 8th time. Okay. So I've got a conversion factor. Did you know you can write it down as 1 mole for every 44.01 grams? Anytime you see a ratio, you can flip the ratio. You know that, right? But this is the first one you think of because it's direct. This is good for getting rid of moles and giving us grams. This one's good for getting rid of grams and getting us to moles. The question asks for grams of CO2. I know there's 11.616. Oh, don't know what happened there. Notice I used all the sig figs. Something that gets rid of mole CO2 gives me gram CO2. 1 mole of CO2, 44.01 grams. Give me a number close to 46. Is it going to be 65? Yeah. I don't know. I shouldn't be guessing on the video. Okay. I'm way off. Look at that. That was way off. 511.22016. And that's grams CO2. Why grams CO2? Because mole CO2 is gone. And I need 3 sig figs. We're going to go with 511, right? Because my 11 point, oh, we got 4 sig figs. Yeah, 4. All right. Yeah. 5 and 11.2. Circling answers. Good. And D. Yeah, you can flip anytime. D, how many moles of water will be produced if 14.52 moles of p-xylene? So I've got moles. As soon as you got moles, you say, hey, it's time for, if I got moles, I can go to moles of something else. So it's time for coefficient. So I've got my 1.452 moles and I want water this time. All right, let's see. I got 1.452. Did I do that right? Yeah, I did. Mole C8H18 or 10. And I want to go to moles. This time I want to go to moles H2O over moles C8H10. Hey, what are those numbers that I'm going to put down? Give me the numbers first. How many moles H2O in the balanced chemical equation? 10. How many moles of the fuel? 2. And what are those numbers called? Coefficients. What are coefficients used for? Converting moles of one substance to moles of another. Very good. We're on a roll now. So 1.452 times 5 is 7.5. I got a little bit of that. 7.26 on the button. So I put a 0. And that's moles H2O. Is that the end of this activity yet? Convert D to grams of water. So we got moles of water. When you want to go to grams, what do you need to use? Anytime you want to go from moles to grams or grams to moles, what are we using? Moles, grams, grams, moles, moles, grams, grams, moles. No, don't use the big word. No, we've already used it. Remember, I said you use stoichiometry once in a question. Guys, this is the same question as the previous one. We're just going for a different way of saying the answer. The coefficient has been used. Don't use it again. Grams, moles, moles, grams is red numbers on periodic table. What are the 2 units on them? Hey, what are the units on the red numbers on the periodic table? Okay, that's what they're called, is molar mass. What are the units? Grams per mole. Okay, we got grams per mole for water this time. H2O. I've got 2 times 1.008 and 16.00. 18.02 grams per mole. It's not an option to get that wrong on Monday. Don't show up. That's the other option. That's how fundamental those numbers are. Grams per mole. That's why we're going to get to 20 on this. You can't not learn something a teacher told you 20 times. Well, you can, but that takes an act of will to not learn it. Okay. Getting worked up. Stoichiometry does that sometimes. And molar mass. This is molar mass. So how do I use that now? You tell me how to finish this lovely question. Coefficients we did do, we're done. That's done. No, don't use them again, please. I want to get rid of the moles from 7.260. Ladies and gentlemen, it's important when you read a question like this, convert the answer to D. You're almost always going to just write down the answer to D to start this problem. Please, you got to learn how to read chemistry. It's a new language. It makes it difficult. I understand. But when it's worded like this, you just copy down your answer for D. Make sure you write moles of H2O, please, so you know what you're canceling. So 7.260 moles of H2O must be converted to grams because it said, how many grams is this answer? Something that gives me grams and gets rid of moles, and we just worked that out from the formula weight, 18.02 grams of water for every 1 mole. And I don't even want to guess that one. 10 would be 180, 150. Say it again, 130. 17. 170.
130. 130.
Sorry. Her lovely accent got me. 130. 8252. Sorry about that. I do like the way you say a 3 by the Okay, grams. Now that I know. 130.825. Does that make sense? Yeah, it does. It's 7 moles. Each mole weighs 18. Yeah. And I need 4 sig figs. What you got? Grams. So you need everything here. It's not like copy final answers. We're getting ready for a test. So I'm going to stop the video so you can finish getting everything here. And that's everything.
But you just check the back of